What happens if laser beams hit rainwater? When the energy of the laser is sufficient, a laser beam can instantly evaporate a drop of water into water vapor. Now, if we fire many beams of laser, can we create a laser umbrella? Making an umbrella with lasers may sound like an easy project, but in fact, its difficulty is comparable to building an atomic bomb. First of all, we cannot produce such high-energy lasers at all. Generally speaking, evaporating 1 liter of water requires about 2.6 million joules of energy. As for the rainfall, it is approximately 0.5 inches per hour. If we multiply these two numbers in a smart calculator, we can obtain the energy required to create a 10 square feet laser umbrella is approximately 12.1 horsepower HP. This number is 10 times the solar energy received at the Earth's surface. And even if we have collected so much energy, when the rainwater is evaporated by the laser, the air will be instantly filled with a large amount of water vapor. This is equivalent to us instantly entering a pressure cooker that can hold an entire person. This high-pressure environment is not something an ordinary person can withstand. Worse still, while evaporating a droplet of water with a laser sounds easy, a large amount of related research indicates that hitting a water droplet with a laser most likely results in the droplet spattering into more smaller droplets. This is what happens when a droplet is hit by a laser. It can be seen that the laser usually only breaks the droplet into more small water droplets, rather than evaporating directly. Therefore, to turn a droplet directly into water vapor, the energy of the laser still needs to be increased, and the increased value may far exceed our imagination. After solving the energy problem, we also need to consider the issue of aiming. In theory, this problem is relatively easy to solve. In modern sporting events, high-speed cameras can capture hundreds of frames per second, the positions of a baseball or soccer ball, thus helping referees make accurate judgments. We can use a similar camera to locate the position of raindrops. Additionally, modern adaptive optics systems can also perform fast and precise control of beams. For example, if we want to cover an area of 1 square meter, we would need to emit about 500 laser beams per second. This frequency is still very low. There shouldn't be any technical difficulties. You might think that I could simply do without an aiming system. I could just randomly shoot lasers. Randomly shooting lasers is indeed easier. But the problem is that the lasers you shoot randomly will not hit the raindrops above your head, because just like how far you can see in the rain, the laser you randomly fired, most likely, it will only hit the raindrops at the edge of your field of view, at least over 328 feet. Therefore, unless you want to make a laser umbrella for your neighbor, otherwise, the laser you randomly fired will not protect you from wind and rain. And even if you have good intentions, wanting to make a laser umbrella for your neighbor, it is most likely that the laser you randomly fired will destroy the raindrops and also destroy your neighbor's house.